This video was brought to you by the ILC. Hello there once again, welcome to episode 56. In this episode, I'm going to show you how to work an exponential growth problem using the concept of compound interest. Let's get started. Our problem today says if you invest $10,000 into an account with an APR of 4% compounded quarterly, how long will it take for the account to reach $20,000? Let's start with the compound interest equation. So the equation goes y equals p times 1 plus r divided by n raised to the nt power. Let's go over what all of the letters mean. Y will be the current value of the account. P is the principal, which means the initial value of the account. The R, here on the top, is the APR, or the rate, as we usually say. The N on the bottom here, and here in the exponent, represents how often the account is compounded. And then T will be the amount of time that has passed. Okay, so let's go through the list and we'll see which of these we know and which of these we don't know. The current value is what value the account is right now, and the question says that we want to know how long it will take for the account to reach $20,000. Let's treat that as the current value. The principal is the initial value. The problem says that we started with $10,000. We'll place that here on principal. Okay. We also need to know the APR rate. The APR is 4%, but we have to write that in decimal form. 4% is the same thing as 0.04, and that's what we are going to use for the APR. N represents how often the account compounds, and it says it's compounded quarterly. So when they say something is compounded quarterly, that means you are compounding 4 times each year. So we're going to let the N be 4. And then the T is the time passed. The question asks how long. So that is going to be our unknown. So now, let's plug everything in, and let's see what equation we come up with. We begin with y, 20,000, equals principal, 10,000, times 1 plus rate over n. Rate is 0.04. And the n is 4, raised to the power of nt. N is still 4, and we don't know what t is. So we have another unknown in the exponent. And as we said in the previous episode, if you have an unknown in the exponent, you're going to have to take the log at some point. But don't do it right now. It's too early. We need to first get the exponential by itself. That means we're going to have to move the 10,000. So let's divide by 10,000 first. 10,000s on the right drop out, and we have 20,000 divided by 10,000. That's 2, equals parentheses 1 plus 0.04 divided by 4 raised to the 4t. Let's also simplify the exponential that's inside the parentheses. We have 0.04 divided by 4. This will give us 1 plus 0.01 raised to the 4t. We can simplify again by adding 1 plus 0.01. So now we'll have 2 equals 1.01 raised to the 4t. So now that we have the exponential by itself on the right side, now is the correct time to take the log. If you had taken it before this, it would have been too early. So let's put common log 2, common log of 1.01 raised to the 4t. Now that you have the logs on board on the left and right, you are allowed to move the exponent. So we'll take the 4t off the exponent and move it in front of the log. So now our equation looks like this. Still log of 2 on the left. The 4t comes down to the front, but I'm going to write it in opposite order for clarity. We'll have t times 4 times log of 1.01. Well, now we just need to get the t by itself. So we're going to divide by everything else. We will divide 4 times log of 1.01 on both sides. Here's the right and the left. So now my answer is this. T equals log of 2 divided by 4 times log of 1.01. If you place this expression into a calculator, you'll end up with t equals 17.45 years. And that's the end of the problem. This is how you solve problems using compound interest. Thank all of you for watching. We'll see you again next episode.